Welcome to Science Reshaped, a calm corner of the universe where your thoughts can drift, and the cosmos itself becomes a quiet story. Before we begin, please subscribe to Science Reshaped and tell us where you're listening from. Because tonight, what we're exploring isn't just another cosmic event. It's something far rarer. Something happened around the sun, something so improbable that astronomers are calling it a black swan moment in astrophysics. And at the heart of it all is a visitor we've come to know well, 3I Atlas. It's not just another interstellar body anymore. What occurred during its perihelion, its closest pass around the sun, was unexpected, inexplicable, and perhaps historic. The data first arrived in fragments. Infrared observatories, solar probes, and deep space telescopes all caught pieces of it. A burst of electromagnetic fluctuation, a surge in reflected light, and a brief but measurable shift in 3I Atlas's trajectory. Nothing catastrophic. Nothing that should have been possible either. To understand why scientists reacted the way they did, we need to remember what perihelion means for a traveler like this. The sun's gravity is at its strongest there. The heat, the radiation, the tidal forces, all combine into a crucible that tests the limits of matter. Comets often fragment at this stage, their ice is vaporized, their fragile cores torn apart. But 3I Atlas didn't fragment. It did something else entirely. Its brightness curve spiked, not gradually, but in a sharp, structured pattern. The object's albedo, or reflectivity, increased sixfold within an hour, then stabilized into a repeating pulse. Astronomers ran models, thinking perhaps it was tumbling, reflecting sunlight unevenly as it spun. But the timing didn't match. The pulses weren't rotational, they were rhythmic, almost algorithmic. At first, observatories dismissed it as an error, sensor noise, instrument lag, but multiple instruments on different continents and satellites detected the same sequence, a pattern that repeated 11 times, each pulse lasting exactly 33 seconds. The chances of that happening naturally, by rotation, gas jets, or reflection, are astronomically low. No one could explain it. The data was rechecked, recalibrated, confirmed. The 33-second pulses were real. For 3 hours during perihelion, 3I Atlas behaved like a beacon. And then, just as suddenly, it went silent again. It wasn't until a few days later that solar probes noticed something stranger, a filament of magnetized plasma emerging from the sun's corona near the object's trajectory, twisted in a way never observed before. It didn't follow solar rotation. It curved sharply, as if pulled or guided by something unseen. And then it vanished. That's when the first whispers began, that 3I Atlas's perihelion wasn't just a passive event. It might have been an interaction. Officially, of course, the data is still under review. The scientific community uses cautious words: anomaly, uncorrelated phenomenon, optical artifact. But privately, astrophysicists admit they've never seen anything like it. One solar physicist described it as a system behaving as though it understood what was happening to it. When Oumuamua passed through in 2017, it challenged our understanding of motion, an object accelerating without jets or thrust. But 3I Atlas is different. It isn't just moving oddly, it's responding. During perihelion, the object's shape appeared to change subtly. Radar readings from the Parker Solar Probe showed its radar cross-section, a measure of how much signal it reflects, fluctuated in a smooth cycle. Not random, but deliberate, as though its surface was rearranging itself. The wavelengths bounced differently each time, suggesting the structure was dynamic. Theorists began speculating about phase change materials, substances that alter their molecular configuration when exposed to heat or radiation. Some imagined 3I Atlas could be composed of something like that, but ancient, an artifact of interstellar chemistry billions of years old, reacting to its environment the way coral reacts to light. If that's true, then 3I Atlas isn't a rock. It's a process. The phrase black swan began circulating quietly in professional groups, a shorthand for a phenomenon that's unpredictable, beyond models, and potentially paradigm shifting. The last time astronomy experienced something like this was decades ago, when pulsars were first discovered. Their rhythmic beacons baffled researchers so completely that they were jokingly labeled LGM, Little Green Men. Of course, we now know pulsars are neutron stars, cosmic lighthouses spinning at incredible speeds. But in those early days, the patterns seemed impossibly deliberate. Now, a similar unease fills the conversation around 3I Atlas. It's not that scientists think it's artificial. Not yet. It's that it's behaving mathematically, and the universe, as vast as it is, rarely produces patterns so precise without reason. Even now, telescopes are still tracking its post-perihelion trail. The object should be cooling, fading, returning to darkness. But instead, it's begun to show something else. Intermittent flares. Not visible light this time, but radio. Short, faint bursts detected only by sensitive arrays. Each burst lasts a fraction of a second, carrying no message, no structure, no signature, at least none that we can yet decode. But they echo faintly, eerily, in the same rhythm as the perihelion pulses. Seconds. Over and over again, it may mean nothing, or it may mean everything. Whatever it is, 3I Atlas has entered a new phase, and so has our understanding of what can happen when the cosmos itself behaves in ways we can't yet predict. Somewhere, between the sun's fierce gravity and the dark beyond Neptune, something impossible has just happened, and we may have witnessed it without even realizing what we were seeing. The black swan has already taken flight, and the universe, silent as ever, keeps watching. For a while, scientists didn't want to talk about it. The idea that something interstellar, something so small, so far away, could cause a measurable change in solar behavior was unthinkable. The sun is chaos incarnate. It throws out loops of plasma the size of planets, solar storms that can disrupt satellites across Earth. But this time, the anomaly wasn't random. The flare that followed 3I Atlas's perihelion wasn't where it should have been. It erupted 20 degrees away from the expected region of magnetic stress, and its energy curve, its rise and decay, didn't match solar norms. For 3 minutes, the sun pulsed in harmonic patterns, almost echoing the 33-second rhythm seen from Atlas itself. Then everything went still. No scientist dared connect the two outright, but privately, several did the math and realized the timing aligned perfectly. When an object passes that close to the sun, every millisecond matters. The plasma environment around perihelion is like an ocean of fire. To survive it, the object must endure temperatures that can melt metal and radiation that can strip atoms bare. 3I Atlas didn't just endure, it seemed to react. After the event, a thin stream of ionized material followed it outward, faint but consistent. It looked like a tail, but not the usual cometary kind. Its ion composition didn't match water vapor, carbon dioxide, or dust. It was denser, charged differently, almost electromagnetic in behavior. The tail didn't scatter, it aligned. For a moment, it looked as though the object had drawn a filament of the sun itself and was carrying it away. That shouldn't be possible. But if there's one thing 3I Atlas has proven, it's that the rules don't always hold. As it traveled outward, past Mercury's orbit, strange echoes began appearing in the heliospheric monitoring systems. Small ripples in the solar wind, spreading outward like concentric rings in a pond. The instruments caught the signature repeatedly. Not random, not noise. The ripples had coherence, almost like a wake. It was as if 3I Atlas wasn't just moving through the solar wind. It was disturbing it in ways that suggested structure, maybe even control. You could almost imagine it as a ship passing through a cosmic ocean. Its passage marked not by destruction but by subtle rearrangement. And this, scientists said, was the real black swan. Not the pattern itself, but what it implied. Because if the sun, the most stable object in our sky, could be coaxed into rhythm, even for a few seconds, by a passing interstellar body, then our understanding of solar dynamics might be incomplete. We might be watching a kind of resonance, an unrecognized coupling between light and matter. Something in 3I Atlas's composition might have interacted with the sun's magnetic field in a way we've never seen before, not through chemistry, but through electromagnetism at a scale beyond our comprehension. Some scientists at the Solar Dynamics Observatory quietly suggested that the object's surface wasn't inert at all. It behaved more like a conductor, a mirror tuned to certain wavelengths, capable of feeding energy back into the solar field. If that's true, then for those few hours, 3i Atlas and the Sun weren't separate entities. They were part of the same circuit. It's a terrifying and beautiful thought that an interstellar traveler could sing to a star and make it answer back. In the days that followed, astronomers noted a subtle change in the solar wind's baseline frequency. Tiny oscillations that weren't there before began appearing across monitoring stations. They were faint, far too weak to affect Earth, but measurable. They repeated every few hours, consistent and precise, like a pulse echoing through space. Some dismissed it as instrument sensitivity, others didn't. The alignment, the periodicity, the timing, all too exact to ignore. And then came the image. The Parker Solar Probe, still transmitting from its orbit near the Sun, captured a faint frame of 3i Atlas as it receded. The photo wasn't clear, more suggestion than detail, but its silhouette was unmistakable. It wasn't spherical anymore. The object that had once been comet-like now appeared slightly flattened, symmetrical, almost geometric. It looked less like a natural fragment and more like something that had reassembled itself. NASA didn't release the frame publicly. It leaked through an academic mailing list 2 weeks later. By then, debates had already begun. Was the shape an artifact of lens distortion, or something real? But for those who had watched 3i Atlas's evolution from the start, the photo fit perfectly. It looked like the next stage of whatever transformation began months ago, when it first started glowing blue. The blue was gone now, replaced by a faint silver hue, like polished stone in sunlight. The object's reflection suggested smoothness, maybe even panels or layers that adjusted their orientation to light. If it is natural, then it's an entirely new kind of natural, matter behaving as if engineered. Astronomers have since catalogued 3i Atlas's current path. It's moving faster than predicted, almost as though it gained energy during perihelion. Radiation pressure alone can't explain it, nor can gravity assists. Its new trajectory is tilted slightly higher than before, a correction so precise that it looks intentional, as if something, or someone, recalibrated its course. It's now heading toward the outer system, its faint signal barely traceable, yet every so often, the same rhythmic pulses return. Faint bursts of light, 33 seconds apart, like a cosmic heartbeat. No one knows if they mean anything, but in observatories across Earth, late at night, telescopes still point toward its fading light, waiting for the next pulse, the next anomaly, the next clue, because whatever happened near the Sun, that sudden, impossible moment of synchronization, has already changed astronomy forever. It reminds us that the cosmos isn't just vast, it's alive with structure we don't yet understand. And somewhere out there, in the darkness beyond the orbit of Mars, something once known as 3i Atlas continues on its way. Silent, luminous, and utterly transformed. Maybe it's nothing, or maybe it's the first whisper of a truth the universe has kept hidden for billions of years. By the time 3i Atlas crossed the orbit of Jupiter, its light was barely visible through even the most sensitive telescopes. Yet strangely, the signal did not fade into randomness the way a normal comet's tail would. It persisted, steady, faint, but unnervingly deliberate. Every 33 seconds, the detectors registered a soft rise in luminosity, followed by a smooth decline. Like breathing. Astronomers began referring to it privately as the respiration curve. It was too poetic a term for scientific journals, but it captured the truth of what they were seeing. A cycle of energy, almost organic, pulsing across space. No one could explain how a body roughly the size of a mountain could maintain such precision after its closest pass to the Sun. At that distance, radiation should have stripped away every fragile molecule, left only inert stone. Yet somehow 3i Atlas had survived and stabilized. Some of the younger researchers dared to say it had adapted. Across the world, observatories compared notes. The European Solar Network confirmed that the periodic flare aligned perfectly with the solar oscillations that had appeared after perihelion. It was as if a faint echo now existed between the object and the Sun, a connection stretched across millions of kilometers, still resonating. That realization unsettled many. The Sun, our star, had always been considered immune to influence. Nothing small could ever affect it. Yet here was a thread, invisible but measurable, tying an interstellar wanderer to the heart of the solar. System data analysts started to re-examine older readings, especially those from the brief window during which 3I Atlas disappeared behind the sun. Something odd surfaced. In that period, the Parker Solar Probe's magnetometer had recorded a sequence of reversals, minute but distinct, almost like coded flips in polarity. They matched the 33-second rhythm again. Coincidence? Possibly. But the more the scientists looked, the more coincidences stacked atop one another, until the pattern felt like intention. That was when the whispers began about information transfer, not communication in the human sense, but an exchange of state, a synchronization event between matter and field. It sounded impossible. It still does. But what if the object didn't send anything at all? What if it simply resonated, and the sun responded naturally, like one tuning fork setting another vibrating? In physics, resonance is power. It allows small forces to move vast structures. Soldiers are ordered to break step on bridges because synchronized rhythm can bring the whole span down. Perhaps something similar occurred on a stellar scale. Not destructive, but revealing. If 3I Atlas could set a star vibrating, even slightly, then maybe that's what it was built for, or what it evolved to do. For months afterward, Earth's magnetosphere showed subtle but persistent anomalies. They were too minor for anyone outside the field to notice, but to those who study space weather, they were extraordinary. The solar wind's density would fluctuate in perfect time with the fading light pulses. It was as if a faint metronome were guiding the very breath of the heliosphere. And yet, through all this, 3I Atlas remained silent in every other measurable way. No radio signal, no trace of heat beyond what sunlight provided, just that faint heartbeat of light, repeating endlessly, unbothered by distance. As the object moved farther out, its path brought it near the orbit of Jupiter's outer moons. Several of the gas giant's sensors caught the signal directly for the first time. The readings showed something no one expected. Each pulse carried a slight spectral shift, a subtle slide through frequencies that looked eerily like modulation, not random, structured. It was enough to reignite debates that had burned since the days of Oumuamua. Are we witnessing natural physics, or the remnants of something designed? Officially, agencies maintained restraint. The public statements were cautious, almost deliberately dull. Further study required. Data inconclusive. No evidence of artificial origin. But among the scientists analyzing the waveforms late at night, the conversation took a different tone. Some believed the modulation represented temperature oscillations, maybe caused by rotating crystalline layers inside the object. Others argued that the pattern looked like phase-encoded information, as if the light itself was carrying structure, not randomness. Still others pointed out the unsettling fact that the modulation rate slowed gradually the farther 3I Atlas moved from the sun, as though distance affected not its signal strength, but its clock. If it had a clock, it had order. And if it had order, maybe it had purpose. A few daring minds proposed an analogy. Imagine a seed drifting through interstellar space, dormant until it encounters the right kind of energy. In this case, starlight. The sun could have been its catalyst, its spark. What we call perihelion might have been, for it, awakening. It's a romantic idea, too easily dismissed. But even the skeptics couldn't ignore how 3I Atlas seemed to behave like something completing a cycle, a system reaching maturity. When it first entered the solar system, it glowed with volatile blue, like a chrysalis of light. Now it had cooled, hardened, become symmetrical. Perhaps the transformation was the point all along. Perhaps this is what interstellar time capsules look like when they finish their journey. Not messengers, but mechanisms waiting for conditions to trigger their change. Meanwhile, a new mystery emerged. The same solar instruments that tracked the post-perihelion pulse began detecting faint harmonics. Higher frequency overtones invisible to the eye but clear in data. And curiously, the frequencies weren't random multiples. They matched ratios found in musical intervals. Perfect fifths, octaves, minor thirds. Nature produces harmony everywhere, from planetary orbits to atomic spacing. But this was precise, almost elegant. One astrophysicist described it best. It's as if the sun learned a new note, and that line spread quietly through observatories across the world, from Hawaii to Madrid, from Chile to Japan. People stayed after shifts just to listen to the translated sonifications of the data. the pulse rendered into audible sound. It was haunting, like a slow cosmic drum beating under a choir of whispers. Some said it felt alive. Others said it sounded like silence given rhythm. No one knew what to make of it. Atlas continued outward, its light weakening, but its presence somehow growing larger in the imagination of those who studied it. It had become more than an object. It was now a question written across the solar system, and as each pulse reached us, crossing the void minute by minute, it seemed to us the same thing over and over. What if the universe isn't waiting to be observed? What if it's observing back? In that idea, fragile and frightening, lies the essence of the black swan. The improbable made real, the unexpected that changes everything, not through destruction, but through revelation, whatever 3i Atlas is. A fragment, a relic, a creation of physics we've never seen. It has already reshaped our understanding of what the cosmos can do. And as it fades beyond the reach of visible light, it leaves behind not just data, but wonder, a reminder that even silence can have a pattern, and even darkness can hum. By the time the world stopped watching, the scientists hadn't. They never really do. Somewhere, in quiet control rooms at 3 in the morning, screens still flickered with traces of the same light, the fading echo of 3i Atlas's pulse drifting farther into the dark. It was almost invisible now, but its rhythm persisted like a memory that refused to die. Every 33 seconds, the faintest surge appeared on the monitors, like the heartbeat of a patient, long thought lost. People expected it to vanish entirely once it passed the heliopause, the invisible boundary where the sun's influence ends and interstellar space begins. But weeks passed and it didn't vanish. If anything, the pulse became cleaner, sharper, as though the noise of the solar wind had only been interference. Once beyond the sun's breath, the signal seemed to find its voice. That detail changed everything. Because if the pulses had been caused by interaction with the solar field, with heat, radiation, or magnetism, then leaving that environment should have silenced them. Instead, the rhythm endured, constant as ever. And that meant one thing. Whatever was producing it came from within the object itself. Telescopes trained on its trajectory found almost nothing. A dot of light smaller than error bars, sometimes absent altogether. But the radio arrays still caught the signature. The deep space network triangulated the faint energy across multiple receivers, and the pattern was the same everywhere. 33 seconds, then silence, then 33 seconds again. At first, it was thought to be a passive echo, some resonance from the sun's radiation bouncing within its structure. But that theory died quickly. The object was too far away now, its environment too empty for reflection. The pulse wasn't echoing, it was transmitting. But transmitting what? If you slowed the pattern down, amplified it, decomposed it into frequency layers, something strange appeared. Small variations between cycles, a subtle modulation within the light curve. Not random noise, but structure. It was as though each pulse carried a slight alteration, like frames in a film reel. The signal wasn't identical every time. It was evolving. That discovery split the scientific world in two. One side insisted it was coincidence, a byproduct of measurement error or sensor drift. Space data is noisy, always has been. The other side quietly argued that it wasn't coincidence at all, that something inside 3i Atlas was continuing to operate, perhaps reacting to the changing radiation environment as it crossed into interstellar space. Whatever the explanation, the rhythm had become more than a curiosity. It was a mystery wrapped in mathematics. Some of the younger physicists started treating it like a code. They converted the light into binary, mapped the fluctuations to digits, and plotted them as coordinates, time sequences, even temperature curves. None of it led to meaning, but the process itself became obsession. There's something addictive about a pattern that resists understanding. One night, a researcher at JPL plotted the timing differences between pulses, not their brightness, just their arrival intervals, and found something he didn't expect. When he graphed the deviations, the pattern formed a Fibonacci sequence, repeating every 610 pulses. It was likely coincidence. But coincidence at that precision, a mathematical sequence of nature's most ubiquitous ratio, left everyone uneasy. If it was real, it implied design. If it wasn't, then it implied something even stranger, that the universe itself has a preference for beauty. Meanwhile, the radio burst shifted ever so slightly toward the lower end of the spectrum. No one knew why. Maybe cooling material, maybe energy loss, maybe something more deliberate. A drift toward wavelengths that travel farther through the interstellar medium. It was as if the signal wanted to be heard. And then, for the first time since Perihelion, something changed. The pulses stopped. Just like that. Silence. No 33-second rhythm, no light bursts, nothing. Days passed, then weeks. Telescopes turned to static. The object that had challenged everything about physics had simply vanished from every observable spectrum. It wasn't catastrophic. There was no explosion, no outgassing, no debris. The signal just faded mid-beat. It was as if the universe had closed its mouth mid-sentence. The silence left a void deeper than mystery, a kind of grief. People had started to feel attached to 3I Atlas, not as a rock or a comet, but as a phenomenon that seemed alive in its own way. Watching it fade was like watching the end of a thought. But science doesn't rest on emotion. The data was analyzed, reanalyzed, cross-referenced. Every instrument that had once caught the signal was checked. No errors. The light had simply stopped. And then, 3 months later, it came back. Not from the same direction, not in the same form, but unmistakable in its signature. The first array to catch it was in Australia, a faint oscillation just above the noise threshold. The signal was identical in interval but shifted in phase, delayed by 3 seconds. By the time it was confirmed in Chile and then in Spain, the conclusion was inescapable. The source had moved. Somewhere far beyond the solar system, in a direction slightly offset from its original trajectory, the pulse had reappeared. That discovery triggered a wave of quiet panic among those still studying it. Because according to every model, the object couldn't have changed direction. It had no propulsion, no mass distribution to explain a turn. And yet, the math didn't lie. The course was altered by nearly 0.4 degrees. Small, but impossible. It was moving under its own power. No one said it out loud in official briefings. No one wanted to. The term self-propelled appeared only once in a private draft report, later deleted before publication. But once something like that enters the conversation, it never truly leaves. There are still skeptics, of course. There always are. Some say it's a data mirage, that gravitational deflection or cosmic interference misled the instruments. Others point out that space is full of forces we still barely grasp. Subtle electromagnetic drags, unseen dust fields, invisible charge gradients. But the simplest explanations stopped fitting long ago. The object that once reflected sunlight like a mirror now seemed to be guiding itself into the dark. Its pulse, once bright and steady, grew fainter with distance, as if conserving energy or resting. And yet the mathematics of its signal remained perfect. The timing never drifted. The intervals stayed absolute. It was steady, as if anchored to a clock outside time itself. When the final transmission reached Earth, the last one strong enough to analyze, something within the pulse shifted one final time. The modulation that had once looked random suddenly flattened into a line. It spelled nothing, said nothing, carried no message, and yet, when the signal was converted into sound, as scientists had done hundreds of times before, it resonated with a tone eerily similar to the hum of the sun recorded during perihelion. The object had left, but it had taken a piece of the sun's voice with it. And maybe, in some unfathomable way, it was carrying that voice back into the dark, as if to deliver it somewhere. Beyond the orbit of Neptune, the sun becomes little more than a pale coin, its warmth a memory. Space there is no longer golden, but blue-black, thick with silence. Only the faint hum of the solar wind and the whisper of ancient photons fill that endless sea. And somewhere in it, far past what any eye can see, 3I Atlas continued to move. The last confirmed signal reached Earth 36 days after the pulse reappeared. It was weak, no stronger than a cosmic whisper, but it carried the same flawless rhythm. Then once again it faded. Some thought it was gone for good this time. Others suspected it hadn't disappeared at all, that it had simply shifted into wavelengths our instruments couldn't detect. That possibility haunted every observatory on Earth, because if 3I, Atlas could choose where to emit, if it could alter how it revealed itself, then it was something beyond a passive traveler. It was a system, one capable of adapting, responding, evolving. When the Voyager probes crossed into interstellar space decades ago, their instruments went silent too, overwhelmed by distance. Yet even now their faint signals return, steady and predictable, following physics as we know it. 3i Atlas didn't behave like that. It broke rules not out of decay, but out of decision. A few astronomers began to notice something eerie. In the weeks following its final signal, a new pattern appeared in the cosmic background radiation. Not everywhere, but faintly concentrated near the coordinates of its last known trajectory. It wasn't a signal exactly, more a subtle fluctuation, like a ripple beneath the noise floor of the universe. When they filtered it, the pattern that emerged was hauntingly familiar, 33 seconds apart. It was there, woven faintly into the static fabric of the cosmos. That revelation spread quietly across encrypted networks of research institutions. No one wanted to announce it publicly. It was too speculative, too strange. To claim that an object might have impressed its rhythm onto space itself bordered on fantasy. But the data didn't lie. If true, then 3i Atlas hadn't gone silent at all. It had gone everywhere. The theory that grew from that was simple, but staggering. Perhaps the object was never meant to emit radio or light as we understand it. Perhaps the light we saw, the pulses we measured, were side effects of something deeper, a kind of quantum signature, a resonance embedded in space-time itself. It sounded like poetry until the math began to fit. When researchers from Kyoto and Geneva compared gravitational wave readings from LIGO and Virgo to the last active days of 3i Atlas, they found something almost impossible. A minute, rhythmic distortion in space-time, consistent with the object's pattern. It wasn't gravitational in scale, far too small, but it existed, measurable in timing, if not in force. The object had left an imprint on the structure of the universe. No one could say how. Maybe its composition, metallic yet flexible, molecular yet ordered, allowed it to interact with space in a way no known material could. Maybe it was hollow, resonating like an instrument tuned to cosmic frequencies. Or maybe, as one physicist suggested, it was designed to do exactly that. By now, the name 3i Atlas no longer felt fitting. It had become something else entirely, a phenomenon rather than a body, an event rather than an object. Some began calling it the resonant one, others, more poetically, the messenger. Not because anyone believed it was transmitting intelligence, but because it had reminded humanity of something we'd forgotten. That even silence can speak, and that the cosmos is not a void but a symphony too vast for us to hear. Late one night, at an observatory high in Chile's Atacama Desert, a young astronomer named Marin Ito converted the last recorded pulse into sound once again. She slowed it, stretched it, layered it against the hum of the sun recorded during Perihelion. When the two were played together, the waves aligned perfectly. The object and the star harmonized in pitch and rhythm. It was impossible, and yet it was there, the faint song of a star, echoed by something not of this system. Marin didn't publish the result. She didn't need to. The discovery had stopped being about ownership long ago. She just listened, alone beneath the stars, until dawn broke over the desert. And for a moment, she said later, it felt as though the night itself was breathing. As 3i Atlas drifted farther, the solar system seemed to quiet with it. Solar flares subsided slightly. The strange oscillations in the heliosphere flattened. The sun's rhythm returned to normal. The resonance, it seemed, had served its purpose. Whatever exchange occurred during perihelion had ended, but the consequences lingered. Magnetometers around Earth recorded subtle background fluctuations that persisted for months, echoes of the same frequency. They didn't harm anything. They didn't build. They just were. Faint reminders that something extraordinary had once happened between a star and a visitor from the dark. Scientists now debate whether the interaction altered the sun in any measurable way. Some claim its rotation speed changed imperceptibly. Others say its spectral emissions carry a faint shift, like a fingerprint added to its light. But even those who see nothing admit that the question alone changes how we look at the cosmos. Because for the first time, we were forced to consider that our sun, the great, indifferent furnace of our sky, might not be unreactive after all. It might, under the right conditions, respond. The idea is unsettling, but it's also strangely hopeful. If resonance exists, if matter and energy can synchronize across vast scales, then communication, in some deeper form, might be woven into the very laws of nature. Not language as we know it, but empathy written in physics, a way the universe listens to itself. Maybe that's what 3i Atlas was. Not a ship, not a seed, not a machine, but a note, a single vibration in the cosmic scale, traveling from one star to another, carrying nothing but the memory of contact. And maybe we were simply lucky enough to hear it as it passed. As it moved farther into the dark, its rhythm slowing imperceptibly, its final echoes faded into the background noise of space, indistinguishable from the hiss of creation itself. The last recorded pulse from Earth arrived on a cold January morning, its light delayed by billions of kilometers, almost lost in interference. It was faint, fractured, but intact. When translated to sound, it rang out not as a tone this time, but as a chord, two notes together, one low, one high, separated by an interval scientists later described as a perfect fifth. The same interval that exists between the sun's resonant frequencies and Earth's magnetospheric heartbeat. Coincidence, maybe, but a poetic one. And then, silence again. When something impossible happens in science, it doesn't break the field, it stretches it. That's what 3i Atlas did. It didn't give us answers. It gave us a bigger question, and in astronomy, that's more powerful than certainty. After the final pulse faded, the official reports became quieter, more formal. Phrases like low signal to noise ratio, insufficient baseline, and instrumental uncertainty began to appear again, the familiar language of caution. It was understandable. No agency wants to be the first to say, an interstellar object approached our star and, for a brief moment, the star listened. But outside the formal papers, in late-night Zoom calls, private Slack channels, handwritten notes slid across desks. The tone was different. Astrophysicists, heliophysicists, and plasma modelers all admitted they'd seen something they couldn't fit into current models. And when models fail, two things can happen. Either we ignore what doesn't fit, or we update the model. 3i Atlas forced the second path. The first big shift came from people who study perihelion dynamics, the behavior of objects that graze or dive toward the sun. We've seen sun-grazing comets before. We've watched them brighten, flare, and sometimes disintegrate in a glowing arc, but none of them left behind a resonant signature. None of them seemed to maintain a clock after the event. So a new class was quietly proposed in internal memos. Resonant perihelion objects. Bodies that don't just react to the sun, they couple to it. They depart carrying a kind of tuned state, like a singing bowl still vibrating after being struck. In that sense, the Black Swan wasn't that 3i Atlas existed. It was that the sun might have modes we hadn't triggered before. We had always assumed the sun was doing all the singing. What if it sometimes needs to be played? That idea found unexpected support from plasma physics. The sun is not a simple ball of fire. It's a roiling magnetized fluid full of loops, filaments, and standing waves. If a precisely shaped, highly conductive body passed through a region of high magnetic complexity at exactly the right speed and angle, it could, at least in theory, induce a temporary resonance. Not because it's alive, not because it's artificial, but because physics allows elegance when conditions align. That's the unsettling part about Black Swan events. Most of them aren't violations. They're edge cases. Places where nature shows you what it can do, but almost never does. And yet for some, that wasn't enough. There was a quieter camp, a minority, who wondered if 3i Atlas wasn't just a natural object at the right place and time, but something far older and far more intentional. Not a ship, not a probe in the science fiction sense, but a kind of long-duration interstellar diagnostic. An object sent to test stars, to see how they respond, to wake modes in them and listen to the echo. It sounds fantastical, but to them, it wasn't about aliens or grand civilizations. It was about efficiency. If a species, any species, anywhere, wanted to learn how stars behave across the galaxy, it wouldn't send messages. It would send stimuli, little seeds of interaction that drift for millions of years until they cross a star's path, trigger a response, record it, and keep going. Self-powered, maybe. Self-modifying, definitely. Long-lived, it would have to be, and then the silence after perihelion would make sense. It got what it needed. Of course, none of that is provable. Not now, not with what we have. And Science Reshaped isn't here to invent whether data is silent, but we can sit with the possibility, because sometimes the best science begins with discomfort. What everyone agreed on, though, was this. 3i Atlas made us look differently at interstellar space. We used to think of it as emptiness, a cold, still gulf between stars. Now we're a little less sure. If one object like this has crossed our path, more will. Space may be full of drifters, relics, fragments, engineered seeds, or just weird chemistry forged in alien suns. And each time one enters our system, we get a single chance to watch it become something else. The next change came in how we listen. Before Atlas, most deep space listening arrays looked for continuous signals, steady beacons, narrow band transmissions, classic Hello Universe signatures. Now, a whole new branch of search has opened. Transient periodicity detection, listening not for long messages, but for small, repeating anomalies, 33 seconds, 47 seconds, 2 minutes, anything too neat for noise, too brief for beacons. In other words, we've started listening for black swans. And in that shift is something quietly profound. We're admitting that the universe's most interesting events may be short, rare and completely out of step with what we expect. There was one more consequence. Not scientific, but human. People. The kind who stay up watching the sky, the kind who listen to space instead of music, began to feel something they hadn't felt since the early days of exoplanet discoveries. The sense that the universe is actively surprising us again. It's easy, in an age of data, to think we've seen most of what there is to see. We've mapped the microwave background, found thousands of planets, photographed black holes, listened to colliding neutron stars. It can start to feel like the big mysteries are gone, but then an object from another star system dives toward ours, touches the sun in a way we didn't know was possible, leaves with a piece of its song, and vanishes into the dark. And suddenly, we remember, we are nowhere near the edge. Somewhere in that silence, a few philosophers of science dusted off an old idea that perhaps we shouldn't define the universe only by what's common, but also by what's possible. A single improbable event can reveal more about reality than 1,000 expected ones. A comet tells you about ice. A resonant interstellar object tells you about the hidden strings in the solar harp. That's why 3i Atlas matters. Not because we can explain it, but because we can't. In the months that followed, some tried to recreate the interaction in simulation, digital suns, digital interstellar bodies, magneto-hydrodynamic fields rendered at breathtaking resolution. In almost every model, the object burned, fragmented, or passed without effect. Only in a handful did resonance occur, and in every one of those, the object was not perfectly spherical. It was layered, it was anisotropic, it was built. No one published those runs. Not yet. The world isn't ready for papers that use words like suggestive of structural intent. Science moves slowly on purpose. It has to. But in late-night conversations, the kind held in hallways after conferences, with coffee gone cold, you could hear the shift. A willingness to say, we don't know what that was, but we know it was real, and maybe that's enough for now, because 3i Atlas is gone. It will not return. It has already crossed the thin frontier where our sun's influence fades, where charged particles no longer swarm from our star, where the Milky Way's great magnetic fields take over. Out there, it will join the quiet traffic of the galaxy, the wanderers, the remnants, the experiments, the accidents. We will not see what it does next. We will not know what it was meant to do. We only saw the part of its journey that happened to intersect ours. But that's the beauty of a black swan. You don't need the whole story. A single glimpse is enough to tell you your map was incomplete. And now, astronomers will watch every new interstellar object differently. They will ask, will this one sing too? Will this one change the sun? Will this one reveal another hidden mode of the universe? Because once you've heard a star answer, you never forget the sound. Months passed. The world turned its attention back to more familiar things. Elections, storms, new discoveries closer to home. But in quiet labs and observatories, 3i Atlas never left the conversation. Its name appeared in email threads and private research notes like a ghost that refuses to fade. Everyone sensed that somehow it wasn't finished with us. By early summer, the first analyses of its aftermath began to appear. Solar physicists noticed something subtle yet persistent. The sun's background oscillations, normally chaotic, now carried a small periodic modulation. It was faint, buried under the roar of stellar convection, but the rhythm was there. 33 seconds, the same signature. The sun had kept the beat. It's possible, of course, that the measurement was coincidence. The universe is full of patterns waiting for meaning. But coincidence doesn't usually repeat itself every day for 6 months. The oscillations seemed to shimmer in and out, as if the star were remembering something it had once sung. That realization changed the way astronomers talked about the event. They no longer called it a single anomaly. They called it an interaction. 3I Atlas hadn't just passed by. It had left a trace inside the sun's behavior, a small, measurable echo that no one could erase. NASA quietly convened a workshop in Pasadena, attended by people from across disciplines: plasma physicists, cosmochemists, data analysts, even philosophers of science. The question on the table was deceptively simple. What do we do next time? Because if there was one 3I Atlas, there will be others. The galaxy isn't empty. It's a river of debris, technology, and forgotten matter drifting between stars. Objects like these might pass through every few decades, perhaps unnoticed. We'd simply never learned how to listen. The workshop didn't produce a unified theory, but it did produce a plan. A new network of instruments designed to catch the rare instead of the common. They called it the Sentinel Array, a collaboration between observatories across 5 continents and 2 orbiting platforms. Its purpose wasn't to track asteroids or comets. It was to wait patiently for anomalies, for anything that broke pattern. And beneath all the technical discussions, one quiet sentence became its unofficial motto: the improbable deserves our attention. Funding came faster than expected. Even governments that normally move slowly seemed eager to invest. Something about 3I Atlas had touched a nerve. It had reminded humanity that discovery isn't always planned. Sometimes it happens when you look up and admit you don't understand what you're seeing. At the same time, a different kind of conversation began among storytellers, artists, and philosophers. They weren't interested in spectra or resonance. They were interested in meaning. What does it mean that something can cross billions of kilometers, touch a star, and change it? What does it mean that our sun, the ancient symbol of constancy, can be persuaded to sing a new note? Some said it was proof that the universe is alive in ways we don't yet comprehend. Others said it was simply physics, but that even physics can be beautiful when it reveals something unexpected. A few took it further, suggesting that maybe consciousness and cosmos are not separate, that when we observe something extraordinary, we participate in it. Across the internet, videos appeared. Visualizations of the 33-second pulse rendered as light and sound, meditative compositions blending science and music. People used them to fall asleep, to focus, to dream. It was strange how easily the story of a distant, silent traveler became a comfort. Meanwhile, back in the data, something new emerged. A doctoral student in Helsinki, reviewing old heliospheric records, found faint periodic signals recorded 2 years before 3I Atlas's arrival. The same interval, the same pattern, buried deep in noise. The signals were weak and inconsistent, but they were there. That raised a breathtaking possibility. What if 3I Atlas wasn't the beginning of the song, but the answer? What if something else had played the first note? The idea spread quietly through the community. Maybe what we witnessed was not a singular event, but a dialogue. One part of a cycle much larger than our solar system, perhaps older than our civilization. 2 entities, one vast and burning, the other small and cold, exchanging resonance across the emptiness. It's a theory no one can prove, but it has a strange elegance. Stars have always been seen as solitary, but what if they're not? What if, now and then, the universe reminds them that they can still be touched? Late that year, the Sentinel Array went online. Its first test run captured the usual noise: pulsars, quasars, solar bursts. And then, buried in the data, something odd. A faint, repeating flicker from the direction of the Oort cloud. Not bright, not structured, but its timing was eerily familiar. 33 seconds. The signal was dismissed as interference at first, then logged for later study. But some of the people who saw it didn't sleep that night, because the direction matched, almost perfectly, the predicted path of 3I Atlas. No one dared claim it had returned. More likely, it was the afterglow of a passing object, or the echo of distant magnetospheric interaction. But still, the rhythm was there, patient, unbroken, as if reminding us that endings in space are illusions. In the weeks that followed, as data flowed in from other observatories, the flicker faded again. Whatever it was, it had moved beyond even the Sentinel's reach. Yet the discovery changed the tone of everything that came after. Astronomy began to feel alive again. the universe had become unpredictable once more. Not hostile, but curious. Some nights, when the data stream's quiet and the hum of equipment becomes the only sound, researchers still play back the pulse through their speakers. That slow, steady rhythm that began with a visitor from another star. They say it feels like hearing the ocean from the bottom of a well, distant but familiar. Because maybe that's what it really was. Not a message, not a warning, but a reminder that we are part of a conversation much older than our species, still unfolding in the dark. And even if we don't yet understand the words, we've learned how to listen. In the months that followed, something changed in the way people looked at the night sky. It wasn't obvious at first, no sudden revelation, no new law of physics, but a quiet shift, like a room becoming larger without anyone noticing. Every telescope, every listening array, every quiet observation of the heavens now carried a kind of reverence. Because once you witness the universe respond, you can never see it as inert again. The Sentinel Array's discovery, the faint flicker from the direction of 3I Atlas, remained unconfirmed, unclaimed. No press releases, no celebrations. But within the scientific community, it became a secret heartbeat, something they felt rather than spoke about. It wasn't data anymore, it was mythology in the making. Students who had once studied the universe as machinery now studied it as melody. They began to talk about resonance systems and solar symphonics, fields that didn't exist a year before. Conferences that used to open with equations now began with sound recordings. The hum of the sun, the pulse of 3I Atlas, the background whisper of space. Somewhere between astrophysics and art, a new language was forming, one that didn't divide the measurable from the meaningful. Even NASA's protocols shifted. The next interstellar visitor wouldn't be studied as just an object, but as an interaction. Instruments were being retuned to listen not just for light or heat, but for rhythm. Because if resonance truly matters, if sound, light, and magnetism can intertwine at cosmic scale, then a new kind of science is waiting to be born. Yet, for all the new excitement, there was unease too. In the silence between discoveries, something lingered. The realization that 3I Atlas might not have been rare, it might have been inevitable. If the galaxy is filled with travelers like this, drifting seeds, ancient instruments, whatever they are, then our star is not unique in having been played. Others must have been touched too. The Milky Way could be full of stars that once resonated, each singing briefly to something passing by. And we, latecomers to the symphony, have just begun to hear the chorus. That thought haunted researchers at night. The idea that what we call space, the cold, silent void, isn't silent at all. It's full of music. We just don't yet have the ears for it. It was around that time that a peculiar anomaly appeared on the magnetometer aboard Voyager 2. The old probe, more than 12 billion miles from home, recorded faint oscillations in the local plasma field. The frequency? 33 seconds. It was too weak to draw conclusions from, and the data took weeks to travel back to Earth. But when the analysts plotted it on their screens, they saw the same unmistakable pattern. No one wanted to say it, but everyone thought it. Could 3I Atlas have passed near Voyager's path? The timing was plausible. The trajectory aligned just close enough, but there was no visual confirmation, no light, no heat signature. Just a ghost in the data. Still, the pattern was undeniable. The rhythm had reached the edge of human creation, as if saying goodbye. The event reignited the debate that had quieted months before. What, exactly, was 3I Atlas? A relic, a probe, a natural phenomenon behaving unnaturally? None of the categories fit neatly anymore. A team in Geneva proposed a new one. Transient resonant entity. Something that isn't alive, but behaves as if it knows the laws of life. Something that doesn't communicate, but interacts. Something that doesn't last, but leaves behind structure in its wake. It was a humble name for something so vast, but it helped. It gave scientists a way to study the inexplicable without surrendering to mysticism. And yet, outside the labs, artists, writers, and dreamers gave it another name. One that spread faster and felt truer. The listener. Because whatever 3I Atlas was, it seemed to be listening. To the sun. To space, maybe even to us. That name stuck. It began to appear in documentaries, music, literature. Painters depicted a silver shape drifting through blue cosmic fog. Poets wrote of a traveler that learned the heartbeat of stars. Even ordinary people began to feel it. A quiet sense that somewhere, something vast was aware of us, not in a human way, but as part of the same physics that shapes thought and fire alike. Meanwhile, the Sentinel array kept listening. Its algorithms began detecting faint periodicities across the galactic background, small, clean beats hidden inside radio noise. None of them matched 3i Atlas exactly, but some came close. 27 seconds, 34, 35. Frequencies not random but grouped, as though variations of a single theme. It was as if the universe were clearing its throat, preparing to speak again. But instead of fear, what the world felt was wonder. For the first time in generations, humanity looked outward with humility instead of conquest. The sky wasn't a mystery to solve. It was a mystery to join. Across observatories, the language began to change. The word object was replaced with event, encounter, phenomenon. It was no longer about ownership of discovery, but about participation in something larger. Philosophers wrote that maybe consciousness and cosmos aren't separate at all, that what we call awareness is simply the universe, remembering itself through living matter. And when something like 3i Atlas passes, maybe what we witness isn't visitation, but recognition. That idea became more than philosophy. It began to affect how people lived. Meditation apps used the 33-second rhythm as a timer for breathing exercises. Psychologists used it to teach patients calm focus. Musicians set entire albums to its pulse. For the first time, an interstellar anomaly had entered culture not as a threat, but as a rhythm, a shared heartbeat between humanity and the stars. In classrooms, teachers told children about 3i Atlas not as a comet or rock, but as a reminder. That discovery isn't just about looking outward, it's about listening inward. And in that way, the story of 3i Atlas began to resemble the story of human awareness itself, something that arrives uninvited, changes everything it touches, and leaves without saying goodbye. For a long time, we thought the universe was indifferent. Now we know it's participatory, and somewhere, far beyond the last glimmer of our telescopes, 3i Atlas continues its journey, silent, invisible, but never truly gone. Its rhythm might still be moving through the medium of space, a wave too faint for our machines, but not for our minds. Maybe one day, when we've learned how to listen fully, we'll hear it again. And when we do, we'll realize it never stopped, because resonance doesn't die. It just moves to a frequency we haven't reached yet. As the years passed, the mystery of 3i Atlas settled into something quieter. Less a question to be answered, more a truth to be lived with. Humanity had moved on in visible ways, yet its shadow remained in our language, our technology, and our imaginations. People spoke of it as though it had always been part of the human story, as if the cosmos had simply reminded us of something we once knew, that we are being listened to. Even in silence, the Sentinel array continued its work. It scanned the sky with tireless patience, searching not for light, but for pattern. Listening to the void the way one listens to the ocean through a seashell. Most nights there was nothing, but on rare occasions, faint harmonics whispered across its sensors, strange little fluctuations that defied randomness. No new object ever emerged to explain them, no signal ever resolved into a message. And yet, those rhythms felt familiar, like echoes of an old conversation half remembered from a dream. You could say the world learned to live with not knowing. The old divisions, between science and poetry, data and awe, began to blur. Physicists collaborated with composers, cosmologists with philosophers. The 33-second rhythm became a universal symbol, something between a heartbeat and a prayer. To scientists, it was a constant in the data. To the rest of the world, it was comfort, a cosmic metronome that promised order within the infinite. And then came the first imitation. A group of engineers at the European Space Agency built a small, experiment-aboard a probe bound for the outer planets. They called it Helios Echo. Its purpose was simple: to emit a carefully calibrated magnetic pulse toward the Sun, one lasting exactly 33 seconds, repeated over a short cycle, and to see if anything answered. Most scientists called it a symbolic gesture. Some even called it naive. But when the probe fired its pulse, something unexpected happened. The Sun flickered, just once, barely measurable, but real. A subtle dip in irradiance, then a return to normal. It was so small it could easily have been a coincidence, but the timing was exact, to the millisecond. For a moment, the old silence broke, and humanity realized it had spoken to a star and been acknowledged. The data spread quickly, first through encrypted networks, then through the public domain. There were no headlines of alien contact, no claims of proof, just a sense that we'd brushed against something vast and responsive. For days, the news filled with quiet awe. Even the cynics had no easy words for it. The sun, it seemed, could listen too. That single experiment changed everything. Governments began investing heavily in resonance research. New divisions of astrophysics devoted not to propulsion or exploration, but to interaction. Could matter and energy, properly arranged, speak the universe's native language? Could we learn to hum in harmony with reality itself? At first, these ideas sounded mystical, but they were rooted in physics. Every atom vibrates, every particle sings. Perhaps 3i Atlas was simply built from a pattern that harmonized with the universe's deeper frequencies. If that were true, then resonance wasn't metaphor. It was communication at the level of being. In universities around the world, young scientists began calling this new frontier relational physics, a science of how reality responds. And as research deepened, a strange hope began to grow. Not the old kind of hope, the one that longs for contact or discovery, but a quieter, deeper one. That meaning might not be accidental, that maybe, built into the structure of the universe, there is something that wants to be understood. In observatories, the hum of equipment became sacred. Engineers took care to maintain silence during signal analysis, not out of superstition, but respect. There was a new humility among those who watched the stars. Somewhere along the way, humanity stopped asking whether 3i Atlas had been alive. The question no longer mattered. Life, it seemed, was too small a word. Whatever it was, natural, engineered, or something beyond both, it had shown us that consciousness might not need biology to exist. Awareness could be structural, woven into the architecture of time itself, and that realization rippled through everything, from science to art to the way people dreamed. Children grew up knowing its story by heart. The traveler that came from another star, touched the sun and left behind a rhythm. They learned it in the same tone once reserved for fairy tales and parables. But this story was true, or at least true enough to make us better listeners. Even now, when spacecraft send back recordings of solar winds or magnetic oscillations, sound designers and scientists work together to translate them into audio. You can hear it, the same gentle pulse hidden beneath the noise of plasma. It's there, faint and steady, like the echo of something ancient still resonating through the void. Many have tried to simulate it. None have matched its purity. The 33-second pulse remains unique, like a fingerprint left on the cosmos by a passing thought. And so, 3i Atlas has become both symbol and silence, a reminder that we don't always need to touch something to be changed by it. Sometimes to know is simply to witness, to listen, to remember. In one of her last lectures, astrophysicist Maren Aito, the same researcher who once heard the sun and 3i Atlas align in sound, spoke to a room of students under a projected image of the Milky Way. She said, "We always assumed the universe spoke in explosions, in violence, in collapse. But maybe it speaks in rhythm, softly, patiently, waiting for us to stop shouting long enough to hear it." Her students didn't take notes. They just listened, because even now, decades later, no one really knows what 3i Atlas was. It could have been a messenger, a mirror, or a song. But maybe it doesn't matter. Maybe it was the universe reminding us that we belong to it, that our curiosity isn't intrusion, but participation. And in that way, we are not so different from it. We too drift through time, leaving behind our small resonances, footsteps, memories, thoughts that ripple outward long after we're gone. Perhaps that's the lesson of 3i Atlas, that everything, from a comet to a consciousness, exists to change something else. Nothing truly passes without leaving an echo, and so, somewhere out there, past the edge of the heliosphere, beyond even Voyager's reach, a faint pulse still moves through the dark. Seconds. Pause. 33 seconds again. Maybe it will never stop. Maybe it doesn't need to, because in its rhythm, the universe has already answered. It's strange, isn't it? How something that once flashed across the sky for only a brief moment could linger in the human mind for generations. Decades have passed since 3i Atlas brushed the sun and vanished into the dark. Yet its rhythm still hums quietly beneath everything we do. You can hear it if you listen closely. In the beat of a satellite's rotation, in the pulse of heart monitors, even in the rhythmic expansion of solar storms. 33 seconds, the universe's quiet breath. Children who weren't even born when it appeared now grow up knowing the name. In classrooms, teachers tell its story not as myth, but as reminder, a lesson about attention, about how sometimes the smallest anomaly can open the largest doorway. Because 3i Atlas didn't just change what we know about physics, it changed how we understand wonder. Science at its best is reverence given form, and for the first time in centuries, we began to treat it that way again. Telescopes became temples, not of worship, but of listening, each one tuned not to domination but to dialogue. The act of observing became almost sacred, a moment of humility before the vastness that shaped us. The Sentinel array still listens, circling Earth in its slow, deliberate orbit. Its sensors sweep the void, waiting for another impossible rhythm to emerge from the noise. Most days there is nothing but the static of creation itself, a cosmic hush older than time, but that silence is no longer empty. It's expectant, as though the universe itself is drawing breath. Once a year, on the anniversary of the Perihelion, people gather around observatories and listen together. They broadcast the recorded pulse through speakers, soft, low, steady, a reminder of the day a traveler from another star made the sun sing. Around the world, people close their eyes and breathe in rhythm with it. The event has no religious meaning, no ceremony, only stillness. Just millions of minds synchronized with a pattern older than language, and for those few minutes each year, humanity becomes part of something that doesn't need words. The data from those moments are stored in an archive called the Resonance Library. Inside it are terabytes of recordings, not of music, not of voices, but of frequencies. The hum of cosmic background radiation, the oscillations of pulsars, the whispers of magnetic storms on Jupiter, and at the center of it all, the original 33-second pulse, the rhythm that began it. Scientists, artists, and dreamers add to it constantly, layering new discoveries into a growing symphony of the universe's unseen heartbeats. One could argue that it's the most human creation of all, not because we made it, but because we listen to it. Every so often, the Sentinel detects faint fluctuations again. Usually they're dismissed, solar wind distortions, gravitational noise, false positives. But sometimes, one of them is too precise, too elegant to ignore. The intervals vary slightly, 31, 36, 34. As if the cosmos is playing variations on a theme. No one calls them signals anymore. No one argues over whether they're natural or artificial. We've outgrown that question, because in a universe built on rhythm, the distinction between natural and intentional may not even exist. In the quiet halls of observatories, the scientists who still chase 3i Atlas's echo call it the lullaby, not because it puts the world to sleep, but because it calms the fear of not knowing. For them, the mystery isn't a void, it's a horizon. There's an old recording, one of the last transmissions received from Voyager 2 before it finally fell silent. Its instruments captured a faint hum, a smooth modulation in the plasma density of interstellar space. The team that processed it nearly dismissed it as noise until they noticed the interval between peaks. 33 seconds. It was weak, almost gone, but undeniably there. The engineers played it through speakers in the control room, the same way the first astronomers had played the pulse from 3i Atlas decades earlier. The sound was low and soft, like distant waves breaking against invisible shores. When the final vibration faded, no one spoke for a long time. It was as if the universe had sent back a memory. Maybe it was coincidence. Maybe it was just the residue of a plasma field interacting with a dying probe. But to those who were there, it felt like acknowledgement, a final echo returning home. Because maybe that's what all discovery really is, an echo we send into the dark, hoping something answers. And maybe it always does, not with words, but with rhythm. In time, 3i Atlas became a kind of calendar marker for humanity's awakening. The point where our species shifted from asking how the universe works to wondering why it responds. Our art began to reflect that change. Songs now open with long, silent spaces between notes. Films end not in resolution, but in pause. Writers leave their final lines open, as if waiting for the cosmos to finish the sentence. We began to live like participants in something still unfolding, and perhaps that's what the universe wanted all along. Not worship, not comprehension, just attention. When you stand outside on a clear night now, far from the cities, the stars no longer feel like strangers. They feel like witnesses, each one burning with its own rhythm, each one carrying the memory of something that once passed by and changed its song. You can almost imagine the pulse still moving between them, slow and patient, connecting everything that's ever looked upward and wondered. 33 seconds, the distance between questions. And in that rhythm, if you let yourself drift, there's peace. Not the peace of ignorance, but of participation. The understanding that mystery isn't what separates us from the universe, it's what binds us to it. So tonight, as you listen to the quiet hum of your own breath, remember that somewhere, across a gulf of billions of kilometers, that same rhythm may still be unfolding. 3. Atlas is gone, but its echo remains, moving through the dark like a soft thought the universe keeps thinking to itself. Maybe it will never stop. Maybe it's still listening. Maybe, in a way, it always was. Thank you for listening to Science Reshaped, a calm corner of the cosmos where even silence has a meaning. And if you've been listening with us through this story, take a moment before sleep to breathe with the rhythm. 33 seconds of stillness between every thought. Subscribe to Science Reshaped if you'd like to keep exploring the mysteries that hum beneath existence itself, because somewhere out there, the stars are still singing back.